Hello everyone and welcome to a new episode of Svelte D3 for data visualization. And today we're going to talk about maps. So maybe you've seen such a map on the web already. So this is a map of the US elections with some nice tooltip, and you can see probably all the different counties. Yes, that's it. I'm not from the US, but I know that there are 3,000 plus different counties and they are colored here. And yeah, basically this is a task you want to achieve in data visualization quite often, that you want to show a detailed map. And one of the approaches to do so is to take a Geojson, which is a data format for such map data, and to transform it into pixels, into reactive pixels and responsive pixels, so that you have a nice map on your website that you can interact with. And we want to have a look today how that works. And for that we are switching into our code editor, and I've already opened a new Svelte D3 project, which is just a fork of my Svelte D3 starter project. The link to this repository is in the description of this video, so you can find it there. And I also already entered like the lines of code that we already used in the past episodes as well, which enables us to put in an SVG where you want to draw the map on, which is responsive, so which is as high and as wide as our pages. And you can already see here, let's make that a little bit bigger, in our DOM, that there is an SVG with a width of 605 and a height of 1328 pixels. And when I change this, like, the width is also changing. So this is a reactive SVG. If you want to know more about that, I refer you to my previous videos in this Svelte D3 series. And I think it was some point we're going to make a standard component out of that, so that we do not have to write this boilerplate code every time. But today, as I've said before, we want to talk about maps. And so first of all, we need a Geojson. So Geojson is a type of JSON that holds information about countries, any type of polygons, shapes, whatever that you can project on a coordinate space. And in our case, we want to use the US and its 3,000 plus counties. And I've already found a link on the internet, which is this Plotly repository. They have some data sets, and they also have the counties of the US as a Geojson, and we could just load that in. How do we do that? So let's just store this link as the Geojson path. And I'm doing weird things, so this is looking like that, and then we need a semicolon here at the end. So we have the Geojson path, and now we want to load that, and this is technically a JSON file, and we have the D3 library already installed, and there is a function which is called JSON. We import that from D3. And then we can use this one. So how can I get a new line in here now? So like this. So we can use the JSON function, and it just takes this argument, which is the Geojson path. And then this is an async call. So we have to call this then method. So as soon as the Geojson is loaded, then we can run this function here. So we get the actual data in there. And we can basically store this data then in a global variable. So let's call that just Geojson. And of course, this variable does not exist yet, so we just create a new global variable Geojson, and that should basically load our Geojson. Do you want to have a look? So let's see, we do a console log of that Geojson, and now let's see if that works. Well, it doesn't work because what I've done here is all but valid. Well, it's valid JavaScript, but it's non-functional JavaScript. So we have to say Geojson equals the data. So we need this assignment here. And now we're going into the console, and we are undefined. And this is because, again, this Geojson is undefined in the beginning, and then it's loading. And this is an async call. But during the loading process, we are already logging the Geojson, which is still undefined. So what we can do is just we can add a $sign here so that we get this console log again when the Geojson basically changes and when it's loaded. And then you see we get here this object of type or with a property type feature collection, and then there's an array with 3000 plus something stuff, and this is the different counties. So this is the feature. So here we see the different counties, and for each of these counties we get a geometry, an ID, some properties, stuff like that. So here you see the name of the county, which I cannot pronounce. But well, that's the Geojson, and that doesn't help us a lot because these geometries that we have here hold coordinates, and it's basically a polygon, but we have no idea what to do that now. So it's minus something, so this might be the latitude and longitude coordinates, and yeah, we need to project this to the pixel space. So we have the coordinate space, so where all our places and counties and countries and whatever are located on Earth in a special coordinate system, latitude, longitude, and we have to project this latitude, longitude into X and Y pixel values that we could use in JavaScript, in our SVG, or wherever we want to draw this stuff. So what we basically have to do is the following. So let me just reload that and get rid of the console log for now so that we get a clear console here. So what we have to do basically is to create a projection, and D3 comes with a high number of different projections, and a very famous projection for the US is the Albus projection. And I have to look it up how it's called. It's called a GeoAlbus USA. So we can import this GeoAlbus USA projection from D3. And that's basically just a function where we put in latitude, longitude, and we get out X and Y values. The problem is that this function does not know how our width and height of our drawing window of our SVG is. And we have to tell that. So we have to modify this GeoAlbus projection. And what we do now is we are creating just a new variable projection, which will be our new adapted projection function. And I'm already putting a $sign here in front because I know that this projection will change when the width and the height or the Geojson of our drawing space or the map changes. So projection is the GeoAlbus USA projection. So we invoke this function, and there is a method then on the projection itself, which is called fitSize. And this fitSize function takes a few parameters. It takes in two-member array the width and the height. And you remember we have the width and the height because we have this bind client with bind client height on the main div element, which has always the width and height of our viewport. So width and height is already dynamic and responsive, and we fill that in here. And we need as a second argument just our Geojson, because the fitSize function needs to know how the dimensions of our map will be, aspect ratio, for example, stuff like that. So with that, we get a new projection function. Yeah, so that's good. And with that projection function, we could already do something. We can just put in the latitude, longitude, and we get pixels. The thing is, what I want to do later is I want to have a path for each of the counties, which is basically a polygon. And this will be now quite cumbersome if I run through all the geometries of the counties, apply the projection to get the XY values, then build a path from there. The good thing is that D3 already has a function which is doing all that for us. It's called the GeoPath function, if I remember that correctly. And what we can do now is we could just create a new path generator. And this path generator is taking the GeoPath function. We are invoking this GeoPath function. This is giving us a generator. and we put in the projection in here, and with that we get this path generator. So now something is wrong, and this is because here my code editor did a somewhat automatic import which doesn't exist. Well, this is already hallucinating here, so we don't need that, just delete it. We have the path generator now, and with this path generator we basically can go through all the features in our Geojson and transform these features to a valid SVG path. So we already see that we are quite close. Okay, so what we do is we calculate now all the different counties with their path. So we take the Geojson, and within the Geojson there is this features array, and we iterate over these features, and you need to write them correctly like that. So you get feature, so we get these features, and we can now return like all the stuff which is in this feature, like there was the properties with the name, ID and stuff like that, also the coordinates. We can just keep them, and we add a new property which is the path, and here we use our path generator and put in, I think it is the feature as such, or it is the geometry. Let's try it like that. We put in just the whole feature into this path generator. Let's see if that works. And then we get back the counties. And what we do now is we just console log these counties, and we see what's happening. And we get a lot of errors. Cannot read properties of undefined reading features in line 13. So here, geojson.features, it cannot read features. Yeah, well, that's because in the initial phase when our app is spinning up, Geojson is actually undefined, so features does not exist. And what we could do is we could just say if there is a Geojson, then fill this counties variable, and if you write it like that, count is not directly after the $sign, we need to define counties, and well, let's just make it an empty array in the beginning. Oops. Now I just jumped in my file. Now I store that, and now definitely we get no errors anymore. So we see here in the initial phase an empty array, and then this array is filled with more than 3,000 values. This is looking good because this is the number of features. So let's look in one of those, and what you can see here is we still have the geometry, we have an idea, and now we have additionally the path. And if you know how to draw on SVG with path, you will remember this is a string which is exactly describing in pixel values, in XY pixel values, how to move a pen on the SVG to draw this specific county shape. In that case, it's the county Hakon. Please let me know if I pronounced this correctly. Well, I'm not good in pronouncing English stuff, but I might be better in drawing map features. So let's get rid of this console log. Now let's go to the HTML part. Now we have the paths, at least the path strings. Now we have all the counties. Now it's time for another each loop, because now we can just take the counties, loop over the counties, get back one of these counties in here. Let me first close this each block, and then we can draw an SVG path. So this is the basic structure, and every path takes the argument, and this is the county.path. All right, I stored it, and wow, we get a map of the US, which is looking very black. We can see some borders, and let's test if this is already responsive. Yes, it is. Very good, because whenever I change the width here, I rerun my projection with the new width, the new height to fit the size. The projection generates a new path generator that generates new paths here for my counties, and they are drawn here. That's what's happening under the hood, and all this wiring is done within Svelte. That's the big plus of Svelte, and we can just draw like this. All right, let's do some cosmetics here. What I don't like is writing county twice. Yeah, that's something I usually don't like. So what you can do here in these each loops, you can use the destructuring operator. So we could already destructure the path here from the county object, and it works. So now you've written 2 times path, but well, that's it. But we can also destructure the ID here, which is, yeah, the ID is here also on these objects, and we can use that in a second. But well, let me do some styling first. So let's make it like that we do no strokes here. Then we do a fill. Let's get a color. So I usually work with purple. Yeah, that's looking nice. So we can do it like that. But, and this is now also a big plus of Svelte, we have here just an HTML element, a path that we could also style in our CSS. So what we can do, we could just write here path, and we can just say, well, fill should be purple, stroke none, and we can get rid of this inline styles here, and it still works. What we also could do is we could put some opacity on it, 0.5. Wow, this is looking nice. Okay, so now this is a responsive map. We want to do a little bit more. I basically want to know which county I'm hovering over, and I want to highlight the county that I'm hovering over here. And the thing is that we have to capture the event that a mouse pointer is entering the path, the shape of the county, the area of the county. And what we can do here is we could just on mouse enter, we could say, well, on mouse enter, let's run a function which is looking like that, where we say the hovered county ID equals ID. So this is just saying that there is some accessibility stuff. I'm not focusing on that right now, so let me just switch that off. So the hovered county ID, let's make that a global variable. So I put it in here. And this is null in the beginning. And now, whenever I have mouse enter, this hovered county ID, which is a global variable, is set to the specific ID of the path element of the county where I'm just in. So if I console log this hovered county, that, and let me just reload, it is null initially, and now when I go over it, you see this is all the different IDs of the counties. Of course, you can build that with D3 only, but then it's imperative spaghetti code actually. So here it's really nice to have this element, to put a handler directly on this element in the HTML. That's what I love about Svelte actually. So it's really good in the combination here with D3. Well, and then let's put on all the active counties a special class. So here comes another Svelte magic. We have this class directive, and this is looking like that. Explained it in a bit, where we say this. So this means if this condition is true, so if the ID of this path equals the hovered county ID, then a class with the name active is set. And I'm not sure if we can see that in code, as we have 3000 different paths, but if I hover there, there's something happening here. Well, let's make it now a little bit more simple. If we have the class of active, we can also access that here in the CSS. So we must do path.active, and we say the opacity that we set 2.5 initially is then 1.0. So let's see if that works. Yeah, so now you see the county I'm hovering over is now highlighted. Here we go. Is now highlighted by setting the opacity to 1.0. This is already quite nice, and it also works like here, larger stuff. And then, yeah, when I move out, it just keeps set to the last that I hovered. Yeah, that works nice. Large county here in Alaska. Well, so now let's make that a little bit more pretty. So what we can also do is we can do a transition, because this is all CSS styling now. We can do a transition of the opacity. Let me think how we build that. Let's take 0.4 seconds and we take an easing in out. Let's see what that does. Now it's quite smooth. What would be really nice is if we have a delay on the fading out, but no delay of the transition when I highlight one. So how could we do that? We could do a transition delay, that one, 0.8 seconds. And I think on the active one, we put a delay of 0 seconds. Let's see if that works. This looks a little bit weird because now we do not get immediate feedback yet. And I think, I just have to do a transition duration of 0 seconds on the active one as well. And now, yeah, this is looking nice now. So it's looking a little bit like Snake. Yeah. So now we have an immediate transition when we hover over a new county. It gets immediately highlighted by setting the opacity to 1.0. And then the active one has a transition back to the normal state, the non-highlighted state, with a transition delay of 0.8 seconds. And that's why we see this trail here behind the mouse. Really nice. So this is a nice effect, which is running completely in CSS. So there's no JavaScript involved for this animation stuff. And really it's, I don't know if it makes sense. It makes sense to show where you've been with your mouse, basically. Nice. But that's how it works. So this is a map in 63 lines of code, basically, where we have a lot of boilerplate code that we could simplify. Maybe let's do that now as the last step. I said I want to have this boilerplate code for the responsiveness somewhere else. We can do that now. So let's create another component which we call responsive SVG. Responsive svg.svelte. And what we do here is we just copy that whole stuff in there. Then we get SVG and a main. And of course we need a script part. So if you were just interested in the map, you can now quit. You can make that as properties. Export let width, export let height. And I take this main stuff out there. Now we're getting errors. This is style. And now this is the boilerplate code I meant before. This is just adapting to 100% view width and 100% view height. And we have to put in this slot element here. So that means that we can put in children also in our component, and we have a width and a height. And then we do the following, that we import this component responsive svg from responsive svg.svelte. And then we use this here as our new wrapper. This is completely untested. I have no idea if it works. And now you'll see that the width and the height, they will be undefined now. So yeah, there's an SVG too much. Let's get rid of that. And responsive SVG. Yeah, so yeah, this is not working at the moment. There are a lot of errors. And you can see here that we get 3000 plus errors because in this path string are a lot of not A numbers, NANs. And this is because the width and the height is still undefined. So we have no chance right now to find out what the width and the height is. We can do that by just bind the properties width to the local, or here in this component, global width variable, and we just bind height like that. And now restart, it's actually working. So make this a little bit, yeah, it's still responsive. And yeah, now we abstracted all the boilerplate. I want to have that one. Abstracted all the boilerplate for the responsiveness to a new component responsive svg.svelte, and we only have now our loop over all the counties. We have some styling there, and we have the JavaScript logic to load the Geojson, to create the projection, to create the path generator, and to recalculate all the different SVG paths for the counties. That's it basically. That's how you build a map with D3 and Svelte, and makes fun. Thanks for watching and see you next time. Bye.